Uh, Good evening, everyone. Greetings from VNIT, and warm welcome to all our esteemed speakers and participants in the 7th masterclass on role of city planning in the mitigation of extreme heat, which is organized as a part of Southeast Asian Heat Health Information Network masterclass. I'm sharing the screen as well. I'm just sharing my screen for. Just a second. Yeah, the snapshot of the agenda is as follows. The inaugural remark will be given by Professor Ajit Tyagi. He is Senior Advisor IRADE and former Director General, Indian Meteorological Department, Government of India. The special remarks will be given by Mr. Rohit Malhotra. He is Deputy Director IRADE. Dr. Vikas Desai will moderate the Q&A and give concluding remarks, and she is Honorary Technical Director of Urban Health and Climate Residence Center of Excellence, Surat. Today's masterclass will be delivered by Dr. Rajashree Kotharkar. She is Professor in the Department of Architecture and Planning at Visvesvaraya National Institute of Technology, Nagpur. Dr. Kotharkar is member of an expert committee constituted by National Disaster Management Authority of India for reviewing heat wave preparedness guidance in the country. She is also Energy Conservation Building Code Trainer at Bureau of Energy Efficiency, India. For the last 25 years, she has conducted detailed research on urban sustainability, climate resilient cities, impact of heat wave on cities and human health, and local climate zone-based approach to urban planning. I now request Mr. Rohit Malhotra to deliver his special remarks. Over to you, Rohit, sir.
Thank you, Nimisha. There is a little bit shift in the schedule, which Nimisha hasn't talked about. But so I will just provide my remarks first and welcome you all to 7th SAHHIN's masterclass on role of city planning in the mitigation of extreme heat. I think heat is a subject which has got the attention across the globe, and this year in particular, when we see in India, so the March was the hottest ever in the history of the recorded temperature in India. And also there has been heat extremes in the country, which are something which are also found in the hilly areas, which earlier such kind of trends were not okay. There is a lot of background noise that got a. Just a second, I will just try to fix it.
Rohit, you muted yourself also.
Yeah, I think there is some background noise which is not under control.
So, now it's okay.
Yeah, so I think city heat is heat as a topic has got the global attention, and we have been seeing that the kind of temperatures which are being recorded not only in the plain areas of the country and the coastal areas, but also in the hilly areas. So the trends are clearly showing that the summer season, which used to generally start from the month of April, now it's we are seeing peaks of the summer also in the beginning, as well as peaks also being reported in the March in several parts of the country. So the heat season is getting longer, and that's where the vulnerability is also increasing, both in terms of preparedness. And though heat action plans are a measure which has been kind of being followed and adopted across the country, which were initiated several years back by the NDMA. But again, the requirements in terms of implementing the actions is somehow which needs further attention. So IRADE has been working on developing spatially differentiated heat action plans, and the work we have done is to develop the ward level heat action plans, so that we identify the vulnerability in particular location in the city, we identify the urban heat islands, so that a targeted action can be taken. So we are extending this work also now in South Asia, taking it to 2 more cities in South Asia, one being Colombo and another being Rajashree in Bangladesh. And we are also revising the heat action plan for the city of Surat. So again, this is a continuous process wherein, you know, we have to evolve the heat action plans to make them spatially differentiated, identifying the urban heat islands. And urban heat islands, they are particularly associated with the urbanization, and city planning is definitely responsible for the same. So the role of the city planning is very important, not only in the mitigation but also in the adaptation. So the way we can target the urban heat islands is very well, you know, by which we can reduce the pressure on the air conditioning, where we actually you know, use the clean energy ways of the transport and also the land use planning. So it's a very important topic what is being delivered by Dr. Rajashree, who is an eminent expert in this area. What I would like to say is that you know, most of the cities in the country, they are showing haphazard development trends in terms of urban planning, and the way the heat is catching us, it's not something which is affecting only our health, but heat can definitely cause mortality in much shorter period, and the loss of GDP to the cities, and also with respect to the other impacts of the demand for the electricity supply, which would further lead to, if it is not clean, then further leading to the more GHGs. So it's a very important issue that we understand the seriousness of the issue in addressing the heat through city urban planning, and also by adopting measures, nature-based solutions for this, looking at retrofitting of the infrastructure within the current cities. So with that brief introduction of the topic and my remarks with respect to the topic today, so I am requesting Professor Ajit Tyagi to kindly give his inaugural remarks. Thank you so much. Sir, over to you.
Okay. Thank you, Rohit, for your opening remarks. Sorry for my voice. I have got cough. So please bear with me. But I joined Rohit in welcoming Rajashree for delivering today's address on important topic of role of city planning in the mitigation of extreme heat. As Rohit has brought out various aspects of heat waves which are taking place, in the intensities of the heat waves, the geographical spread of heat waves, and the time period during which the heat waves are being affecting the larger population of the world. So with these things happening, this year is a live example that March being the hottest month for the world, also for India in last 150 years of its observations. Now, SAHHIN has been conducting a series of master classes. SAHHIN is the South Asian Heat Health Network to promote awareness about the heat waves and initiating the various preparedness, mitigation, and adaptation measures related to the heat waves. The focus on South Asian countries. Now, as Rohit has brought out, urbanization. See, this is already 50% of the population of the world, but in the developed countries is residing in cities. In India also, we are touching 30% mark and will reach 50% mark by another decade or so. Cities are economic drivers, and people migrate from rural areas for search of jobs. Now, if it is well-planned migration and cities are able to accept these migrant workers, seamlessly in their planning process, the things would have been different. But unplanned development has led to a lot of problems, and heat related is one of the major problems which is being faced by the cities. We have a urban heat islands, which is now a well-known observational feature of the cities, where temperatures in the heart of the cities, where the density of the buildings and population is high, can be as high as 8 to 12 degrees centigrade from the rural neighborhoods. So that gets obviously associated problems, especially in the slum and poor areas of the city. And therefore, any mitigation effort in the city has to have ward level, not only even at ward level, even the city level, street level, urban vulnerability mapping and the risk assessment. Because the streets which are busy, traffic, even have a higher temperature than the urban heat islands. They are the hottest spots because of the traffic and paved roads, and also the lot of people working, the policemen, the labor force, the vendors, which all are exposed to the extreme heat in the streets. Now, how do we cope up with this? Urbanization is taking place. This is a hard fact. More and more people are migrating for the search of jobs and livelihood, and cities are not able to assimilate them in a climate-friendly manner. Now, for this, we have to have a proper city planning for mitigating the adverse impact of heat. Because what we are finding is that cities are also contributing to global warming because they generate a lot of heat. The temperatures are higher, so the mean temperature goes up, and that contributes to global warming, which in turn, so it's a vicious circle. City gets affected because of global warming. Urban heat islands take place, and that they contribute to the global warming. So we have to, if we have to arrest and mitigate global warming and the urban heat island effects, the city planning can play a very important role. Unfortunately, that has not taken the priority in our policy making programs. We continued to develop our cities in an old fashion, whereas the new technologies, which should be green energy based, will be able to, I'm sure, able to reduce the heat footprint of the cities. And there couldn't have been a better speaker than Rajashree, who has been working on this aspect of sustainable cities, and she has agreed to deliver today's lecture. She is associated with various initiatives at the national level under the NDMA, the heat wave guidelines. See, already the importance of heat action plans have been highlighted. Many cities have developed these heat action plans, and that has been able to reduce the heat wave related mortalities. But then we have to further improve, as Rohit has brought out. This cannot be a single threshold for entire city for the heat wave, and preparedness and the mitigation have to be related to the vulnerabilities and the risk of heat waves. So that is very important, and I'm sure the cities, as they become more aware about the fineness of and the spatial variability of heat related factors in the city, will incorporate them in their heat action plans. And this particular today's talk for medium to long-term planning of cities will be able to factor these important steps taken. The cities will be much cooler and sustainable, habitable, and will not contribute to the global warming as it is taking place now. Thank you. And once again, let me compliment Irade for organizing this particular masterclass, the series of the master classes which they have been conducting. This being the 7th masterclass, and she addressed various important issues related to the heat action plans and the preparedness and the response to the growing threats of the heat. Thank you, and over to Rajashree.
Okay, I am sharing the screen now. Can you all see the first slide?
Yes, Dr. Kotharkar.
Okay, great. Thank you. Thank you so much. A very good afternoon to everyone. And I think last week of April is the right time to talk about heat. And we've already had multiple heat wave instances in India. Rather, we've been saying that March has been the hottest month in last 112 years. So this is, and as we know that this is going to be a major concern in coming days. What I'm going to speak about is extreme heat in the context of what is it that we can do maybe at the city planning level to address the issue of extreme heat. We'll go through this in with parts. So there'll be 4 parts of the presentation. First is we'll talk about the extreme heat and cities. Then we'll try to understand cities because there'll be people who are non-planners, non-architects here. So just to give a reference and connect it with city planning, I'll just give you what is it that we mean by cities, and then talking about a spatial framework, the need for a spatial framework, and lastly, if there is one, what kind of application does it have in terms of the mitigation? And before you mitigate, you try to understand the issues linked with extreme heat, which as some people have already listed it, that UHI is one of them, heat stress, excessive energy consumption. So we'll just have a look at it. We all know that heat is going to be a major concern, and in years to come, heat wave is certainly going to be one of the major concern. It is on a top list when it comes. There are strongest evidences that it is going to be a major concern. Can cities provide a solution? Yes, because they are a part of a problem, in the sense they are the ones that change a lot of things and create a certain kind of microclimate. And most importantly, since people live in cities, if cities become warmer, they become vulnerable, it kind of increases the morbidity and mortality of the people, and that's why the focus on cities. So there is a certain focus on cities, and then when we talk about heat action plan, we essentially talk about it in the urban context, as the large section of people stay in the cities, and then in years to come, more and more people will be staying in urban areas. So that's why cities become the focus. 2 types of heat waves that we have. Essentially, when you have dry heat waves in certain climates and you have moist heat wave, I'll not get into the details of that, but each one of the major concern with heat wave is that each place there is no such definite definition of the heat wave, but IPCC currently says that a continuous period of abnormally and uncomfortable hot weather is something that we call as heat wave. And that's what we understand as an extreme heat event. And we are trying to understand the mitigation of this extreme heat through city planning. In next few years, what we are going to see is large part of India or South Asia, since there is a large population which lives there. So one is large population is living in the South Asia. Secondly, it's extremely dense and it is vulnerable to heat waves. So by 2015, you will have a lot of settlements, a lot of areas which will be in the grip of heat waves. Now, what are the concerns that what does it lead to? Maybe heat stress. It leads to high energy consumption, excessive mortality, damage to infrastructure, high hospital admission, that is the morbidity, and there is a huge economic and labor productivity loss, which we are still not started working on or calculating what is the economic loss of the heat waves. if you see the historically how the response to extreme heat has been at the global level. So we kind of started responding maybe in 1995 when the first heat health warning system came into being in Philadelphia. And over a period of so many years, we've developed in 25 years, we have a framework for heat action plan. And if you look at the guidance that is provided by WMO, WHO, we already know there is a framework in place as to what should be the content of heat action plan and what is it that one needs to do. The basic objective of heat action plan is to reduce the mortality and morbidity during the extreme heat periods. So, and just to give you a glimpse of what is happening in South Asia. So most of the, if you look at the policies that we have in South Asia at the various partial levels in terms of the management of extreme heat, you will realize that most of the countries have proper policies at the building level. Some of them have at the neighborhood level. But when you look at the city level policies, all of them, they are in parts. So the IGBC township is there, or maybe the Green Climate Fund is there, but there is no such concrete. As we start going up in the spatial scale, there is not a very concrete policy to deal with the extreme heat as far as the South Asia is concerned. Now, there have been 47 countries that have a heat action plan in the world, and Africa doesn't have a single one. And so we kind of tried to understand what has been happening in the heat action plans that were prepared world over by various either cities or countries. So some of the shortcomings that we have as of now is none of them essentially focus on long term. In the sense, they're not trying to integrate city planning with the heat action plan. So if you see the list here, these are the three core elements of the heat action plan. The 4th, 5th, and 7th are connected with the built environment. That is reduction in the indoor heat exposure, particular care of the vulnerable group, and the long-term urban planning. Now, these three major components of the heat action plan are linked with the built environment management and planning. And we'll be focusing on this. And most of the heat action plans that are prepared world over globally are not really addressing to these three aspects in detail. Cities, how do cities essentially have the effect? That means you have the built environment, that means you have an urban morphology. So we'll talk about the various components of urban morphology. Essentially, the change in land use and land cover takes place and you have a city. So that is one component of city. The other is the anthropogenic heat that is being generated within the cities due to the anthropogenic activities. And that collectively, you can say, forms the built environment. And then there is a requirement of human comfort that we have, or health. That means you require a certain kind of comfort, thermal comfort, outdoor as well as indoor. And the heat wave is trying to, the climate is trying to interact with the built environment and create a certain kind of microclimate within the city. And that is creating a problem for the human comfort. And in the whole process for providing comfort, you use energy, which in turn, generates a lot of anthropogenic heat. So how is it that we can work on this triangle well and make changes in the built environment in such a way that it responds to the climate and in a way provides the human comfort that is required. Urban heat island, which was being talked about in the initial two speakers who were introducing the masterclass, kept talking about urban heat island. The simple definition of urban heat island is when the cities become warmer, cities are rather they're warmer than their countryside, and they create an island of heat, and that's what we understand as urban heat island. Though, this is in a very, very simplistic term that we're talking about what city does and what the morphology does to the microclimate, and why then, and that is why change in that morphology or change in those parameters can in turn change the microclimate of the city, and in a way can reduce the impact of cities on climate change. So it works both ways. So when we talk about UHI, what are the parameters that affect the UHI? That means that create positively or negatively. So one of them is sky view factor. We'll see what sky view factor is. The green areas, the building material that is being used, and there are parameters that are population related, that is the anthropogenic heat and the air pollutants. They all either positively or negatively impact the urban heat island intensities, and these are the parameters which we can control, in the sense you can change the green cover in the areas, you can change the sky view factor by changing the placement of the buildings, you can change the building material. So this all becomes a part of city planning. Population can be distributed the way we want. That means you can have a density control in the cities. The anthropogenic heat, in the sense you start planning the transportation networks properly, automatically it will have an impact on anthropogenic heat. You have greener buildings in the city, they will automatically have less emission, and that will reduce the anthropogenic heat. And less of all this will automatically reduce the pollution and will have, you will have lesser urban heat island intensity. So these are the parameters that essentially in a way define the city, and they are the ones that need to be managed when we start talking about city planning for the mitigation of heat. Several studies have been done to tell us that during the heat wave period, the UHI intensities also intensify. So you have higher UHI intensities during the heat wave period. So heat wave is, we all know that it is defined in India, it is defined on the flat, terrain, it is 40 degrees Celsius plus temperature when you have, it is declared as a heat wave. IMD declares the heat wave. So you have different, temperature parameter for different areas. So you have a mountainous area, the temperature is different. You have coastal areas, it's different. And in the plains, it's different. We'll be taking up a case study and trying to understand exactly what happens when you have planar cities and exposed to heat, what kind of variation happens within the city. And as I was talking about the morphology, how does the morphology affect? Heat is released by the building material has a tendency to store heat, and even not, since you have a large thermal mass, it kind of tends to store the heat and it releases throughout the day, it is absorbing the heat, in the night it is releasing, making the whole area warmer during the night. Since you have so many buildings and there is lack of vegetation, so it does not provide the city an opportunity for evaporative cooling or any kind of shading. So all areas are exposed to sun. That leads to excessive heating. Anthropogenic heat, as I said, through traffic and heating and cooling of buildings, again adds to the heat. Tall buildings, they create they trap the air, they create various street canyon, and they reduce the wind speed, through which they do not allow the city to get ventilated. That is also an issue. And between the different surfaces, the radiation gets blocked, and that kinds of heats up the cities. So all these parameters that we have talked about, they are all morphological parameters. That means they are the parameters which are governed by city planning. A small change in the city planning measures, and one of these parameters would change, and that would finally impact the microclimate of the city. So just trying to establish the link between the urban morphology and the microclimate that we have, and trying to establish a fact that city planning itself can become a solution for the extreme heat management. But then we all know there has been a lot of study done. We all know that heat gets trapped when you have a deeper canyon, when you have building materials that absorb heat. But one must have a framework to solve this problem. So world over, there has been an attempt to develop a framework to study urban heat island, or rather heating of the city. So just to give you a background, like I said, that urban heat island is just delta T. That means the cities has a higher temperature and the countryside has a low temperature. So you take the difference between the two, whatever you get is the urban heat island intensity. But it is, since it's not very simple, since the city is not a homogeneous entity. In the sense, if there is a city which has a large park, that will have lesser temperature than the area which has a high built-up density, which is a downtown area maybe, which will have a lot of buildings very closely placed, that will have higher temperature maybe. So within the city, so you don't have that T urban that we keep talking about, TU, which we call as temperature of the urban area, is not one single entity. Different parts of the city will have different temperature regime, and this delta T is going to vary from place to place. So you have an urban park, the delta T for the urban park will be different. You have a large lake in the city, the delta T, that means the temperature of the lake, air above the lake, and the temperature of the countryside, that delta T is going to be different. If you have an old area with densely built buildings, the delta T, that means the temperature of that area, the difference between the temperature of that area and the temperature of the countryside, that difference is going to be different. So the UHI intensities are going to vary throughout the city. This is where the requirement of the framework comes from. And that's why it will be unscientific to just talk about UHI in the context of just one delta T. That is temperature, urban temperature minus rural temperature. That cannot explain the complex phenomena of UHI. And that's why there comes a framework. So the city can be classified in different local climate zones. Local climate zones are defined on the basis of multiple parameters. So this is the list of the parameters that define the local climate zone. Sky view factor, aspect ratio, building surface fraction, that means how much surface in that area is being occupied by the buildings. Impervious, that means where the water cannot enter into the ground. Pervious, where the water can enter. What is the heightness of the roughness element? Roughness element is the building and the trees both. What is the class? The class we don't have to talk about that. What kind of albedo does it have? That means how much of the heat that is falling onto it is getting reflected, and what kind of anthropogenic heat output is there in that area. Based on that, based on these parameters, one can classify the city in multiple local climate zones. So this is a classification which is being used worldwide by most of the geographers and urban planners to classify the city to understand issues related to heat. This LCZ temperature is the governing factor for this classification. So this has been used by a lot of people. I would say almost all countries have LCZ the cities that are being classified on the basis of these zones, LCZ. So there are 10 built-up zones based on the height of the building, how closely they are placed, and what is the anthropogenic and what kind of vegetation it has. So there are something like 10 classes in built, and there are 7 classes in the natural. So there is a class for water, so lake will come in LCZ G. There is a class for dense trees. So any area in the city which has dense trees will become LCZ A. So when we calculate the delta T, you will calculate it for LCZ A. So we'll get to know what are the UHI intensities in LCZ A, rather than saying that this is the UHI intensity throughout in the city. So this is the framework. And as an urban planner, I always felt that you need a spatial framework if you have to take any action, because all mitigation adaptation measures require to answer 2 questions: what to do and where to do. So to solve the question where to do, the spatial framework is required. What to do, you require these parameters and their relationship with the temperature to know whether you need to plant trees, whether you need to have whether you need to reduce the building density, what is it that you need to do. So that question can be answered through the parameters. This is just to give you an idea how do these LCZs look like in the city. So these are some of the examples. This is LCZ 9, where you have, this is LCZ 6. This is a slum, squatter settlement rather. So which we call as LCZ 7. The first one is LCZ 3. So you have the variation in the kind of morphology that you have in the city. The LCZs are defined. So I'll just run through one. So these are some of the LCZ maps that we find throughout the world. Colombo has, people in Serbia have done it. There are a lot of cities in Europe and China where LCZ mapping has been done, and that is being used to understand heat stress or to mitigate or to have adaptation measures based on that. I just thought that I'll explain the importance of these parameters further. So building fraction, building surface fraction, and whether it is impervious surface or whether you have vegetation density. If you can see these, you can see my cursor, and changes, variation in the building surface fraction actually has an impact on LST. So these are the parameters that have a direct impact on the temperatures in the city. And it keeps changing over a period of time. As humans, we have a tendency to keep changing the land cover. So we keep changing from forest to agriculture, agriculture to urban, urban to very, very urban. This figure that you see is the sky view factor. That means the amount of sky that you can see. So which kind of works both ways. It allows the heat to enter into the canyon, and it also provides an escape for the heat in the night. So it provides for a radiative cooling in the night, but at the same time, it increases the solar exposure of that particular canyon. Same thing is true with the aspect ratio. You can see here, which is the height to width ratio of the roads, streets. So now we'll see how the application of this local climate zone classification. I'm just going to show you the study in one of the Indian city, especially, in Nagpur, where we have done it, and show you how this can be used as a framework to understand a lot of things and also provide mitigation measures in the context of a city. So this is the LCZ map that we have of the city, which has majorly it is 3. Some other LCZ classes are embedded in 3, in the sense you have a large area, maybe, but which is not pure 3. Typically, you will see low income cities in India, which are very dense, and low income cities. They have a very heterogeneous nature as far as local development is concerned. And mostly the local climate zone maps that you will get will be extremely heterogeneous, and they will also have LCZs where one LCZ is embedded in another. So you'll see a part of 2 in 3, maybe part of F in 3. So we also did this, the classification where you have 2 LCZs combined together. So these are the LCZs that you have in Nagpur, where the maximum percentage is of 3 and 9 also. The first thing that we tried to do was to understand whether all LCZs have the same temperature during day. So this study was done for the day and during night, because if you want to talk about extreme heat and provide a solution, you must understand how each LCZ behaves during the day and night. So all the important, in the sense, critical LCZs were identified. Criticality was based on the this extent to which the city is covered by these LCZs, and secondly, the number of people that stay in there. So 90% of the population lives in these LCZs, so they were chosen. LCZs where very little population lives, a very small percentage, we've not taken that. And we conducted, so this was done for the whole during the day and night. So the whole day we took the mean of that day, and this is a group mean that you can see here. some here. This is the group mean, so that becomes 0. And anything, any LCZ which has more temperature than that, that is on the positive side. Any LCZ which is cooler than the group mean goes on the negative side. So there are these LCZ 9, which is very hot as compared to the group mean, which is on the fringes of the city. Same thing is true with it in the night also. But the LCZ 3, which is extremely dense, old area, very, very dense, that is hotter during the night, but cooler during the day. So as I was trying to make this point that the whole city doesn't behave in the same manner, at the same time, there is no such thing as heat stress only during the day. So there is, when we talk about heat stress, there is a nocturnal heat stress also. And some of the areas might experience nocturnal heat stress, whereas might not have heat stress during the day. To understand this as to where, that is what I said, that 2 questions, where and what. So where is this happening? LCZ classification provides us the framework to answer that question, where is that happening? And what needs to be done? Once you know the morphology, one can solve the question, solve the problems based on the morphology. So we'll be talking about that as well. So we first took the thermal anomaly, in the sense, what is the variation in the temperature? The second thing that we tried to do was, in the first place, only temperature was taken as a parameter of extreme heat. In the second one, we used heat index, which is used by NDMA also. In India also, we're using heat index. It is one of the index to measure the heat stress, where the air velocity, where the relative humidity and air temperature both are taken. And there is a particular algorithm you go about doing it, and it also tells you at what level does it really become an extreme heat stress. So this gives us a good understanding of the city, that the whole city is not going through the heat stress all the time. So if at 2 p.m. this is mapped for 2 p.m. So if you see these areas where the vegetation is little more, they have a different heat stress condition as compared to these areas. And you see the fringes, they have higher level of heat stress at 2 p.m. They still have a higher level of heat stress at 2 p.m. And at 11 p.m., when these areas are cooler, there are certain areas which still have heat stress, certain level of, I'm not saying extreme one, but just to make a point that you need a spatial framework to understand what is happening, how the heat stress varies through the city. This is trying to tell you that if we have 24-hour study, these are the LCZs that we are talking about. We used 2 indices here. One was heat index, the other was humidex, and trying to understand which of them stay in the heat zone, under heat stress for a longer duration. So this is the one which stays in the heat stress for a long duration. Same thing is true here, that LCZ3 becomes critical because this hour also it is staying in the heat stress for a longer duration. So overall, if you see, it stays in the heat stress for a longer duration. But 9, if you see, then it has the higher intensity of heat stress for a longer duration. So for a certain time, it has extremely high intensities of heat stress, whereas after that, maybe it becomes cooler. So that is also required to be understood, that what kind of morphological compositions lead to what kind of heat stresses, whether it is consistent, moderate, or high level of heat stress for a long duration, or you have extreme heat stress for a shorter duration. One can accordingly take measures based on this understanding. Then we tried to understand, so trying to reinforce that morphological parameters are trying to help, and LCZ can be used as one of the framework. So we then used the concept of cooling degree days to calculate the energy consumption in these LCZs. So we used 2-3 methods to calculate the energy consumption. If you can see that this is the zone which has higher vegetation. If you compare the energy consumption of this zone with the other, so the fringes have close to 20 to 21% higher energy consumption than this zone. So if you start looking at the consumption of energy, so what will happen that you start consuming more energy, there will be more anthropogenic heat. So it is varying the energy consumption in the city, and certain morphological parameters are helping this LCZ use less energy, and it becomes energy efficient maybe as compared to the other LCZs. So this is a huge variation. I mean, 21% more than the one which we took as a reference. So we took this as 0, took it as a reference, and as against that, the other one had 21% more energy consumption. We tried to put all the three together and tried to see how each one of them behaves. So if you see the LCZ9, which is the fringe areas, it has the major issue when it comes to energy consumption. Whether it is daytime, nighttime, it consumes a lot of energy. And next is LCZ3. So one can then conclude that these are the two LCZs. One is LCZ3, where you have medium height development with very extremely dense building placement. And the other one is where you have not really very open kind of a development of buildings, but it is, since they are all exposed, they're in the fringes and the vegetation is less, that is also creating an issue. So these two LCZs become very, very critical. The other thing that we already know from the literature review and the studies that people have done, that urban form and its layout, it affects. Then you need to have efficient urban systems, you need to have green infrastructure, building material you can change. So there are, we know, multiple mitigation measures that are there. So what we tried to do, but the question is whether all LCZs will have the same result if you have one particular mitigation strategy. That means if cool roofs are a mitigation strategy that I want to use, will it work in the same manner in LCZ3, LCZ9, LCZ6? Should I ask everyone in the city to use cool roof, whether it works? So to understand that, what we did was we took three LCZs, LCZ3, LCZ3F, and LCZ9. So all three of them have different morphological configuration. And we tried to use 4 mitigation measures. One was using cool roof, keeping everything else, just paint it with cool roof material. Second was you start planting the trees along the, second was cool pavements. Third was you start planting the trees along the streets, which we could not use. If you see the table here, we could not use it in LCZ3, that is the core area, because the street width itself was so small that there was no provision to plant tree there, so we did not use it there. The fourth one that we used was out of the, taking the total area, convert 12.5% into a green area, but at one single place. So instead of having a scattered all trees all along the street, just have one large green space here. And whatever built up buildings you had there, we distributed them on the other buildings. So the overall number of occupants remains same. Same thing we did here, same thing we did here. And the last one was converting 25% of the area into a green cover. So you increase the green cover in those areas. And trying to understand and evaluate these 5 mitigation strategies as to how they help reduce the temperature in these 3 LCZs. To get, the question here is whether all mitigation measures help, whether some of them help in some LCZs, or we should just go for one single mitigation strategy. So the results that we got, and so this was the, if you see that this is the simulation result that we have. So essentially what we have is the mitigation measures at the building level in the first case. Second and third, we have mitigation measures at the street level. And fourth and fifth, we have the mitigation measures at the area level. So building level becomes much easier. So we divided it into 3 parts because the implementation is also an issue. You must have it based on how you will implement it. So if you see, finally, the results that we got, the effectiveness of these interventions depended on the urban density and built characteristics of a particular neighborhood. And all of them did not give the same results at the end of the day. But trees along the street was one of the best mitigation measure. Rather, some of the 3F, we did not get good results for cool roof. So it kind of sums up that when we are talking about urban morphology and the mitigation measures, what kind of measures one would be required to take. So urban planning becomes an important part in terms of whether you want to change the vegetation. We did not go into the major structural changes, but what I'm coming to is the various LCZs. While you plan also, if you know that whatever city plan you have is going to lead to this kind of LCZ, you already know what is going to be the temperature regime of that LCZ, because the study is already done, which type of development is going to be hotter. So based on this now, we can, when we develop development control rules and regulations, we can have the controls accordingly. When we control densities, build densities, FAR, we start working on this the other way around. Now, since we know this, accordingly, the DCR can be developed for a particular city. I think so that it kind of sums up that the parameters that we started with essentially are the ones that collectively decide what urban planning measures are taken throughout the city. So urban planning policies are linked with these morphological parameters, and that's why change in them leads to the changing temperature regime. So finally, it is linked with the city planning measures that we take. So that's the point I wanted to make. So I would say that what we need as a long-term measure to mitigate, to manage the extreme heat is fundamental changes in the way we do our city, the way we plan our cities, other than the other measures that we do. That's it. And I would like to put this on record that I'm thankful to all my students who have worked with me and the agencies that have funded the work that is just presented here, to make a small point that city planning is the key to management of extreme heat. I guess I took a little more time maybe, but that's it. Thank you so much. Thank you. I hope I finished in time.
Thank you, Dr. Kotharkar.
I can't hear you.
Thank you, Dr. Kotharkar.
Yeah. Now I can.
Over to you, Dr. Vikas. Vikas, ma'am.
You see, very exciting study and experience sharing, and I congratulate Dr. Kotharkar for this. And I am sure, and I'm reading in the participants' notes, that everyone enjoyed and learned a lot from this presentation. We have one or two questions. If somebody, you can read, Nimisha, for the details.
Yes, ma'am. The first question is by Mr. Rahul Mishra. He says, LST calculation have been the backbone of studying UHIs. My question is how LCZ classification can be used to study UHIs, especially with respect to heat mitigation capacity of blue-green infrastructure. In bracket, he writes cooling intensity of the BGIs. Bracket.
Dr. Rajashree?
Yeah. Sorry. So I think I'll divide this question into two parts. The first is how the LCZ classification is used to study UHI. That's the first part of the question. You can study it. I mean, initially one will have to map the LCZ classification. That's the first job. Overlay it with the LST, and then try to understand what each LCZ's temperature range is. So typically that's how we do, and there are so many papers, people have done it. You can do the same thing for the air temperature also. And the second part is, how do we know that blue-green infrastructure, whether it is helping? The same thing, I mean, the results from the first part itself will kind of start talking about whether the greener areas that you have. So further study at a much finer scale, when you start doing, one will get to know as to what is the extent. Say, for example, like I'm saying that if you have trees along the street, it is going to help. Is it going to help you more? Or you have a large park in the neighborhood, is that going to help? So those are the kind of studies that we'll have to do through simulation, because they are all what-if scenarios, and kind of, you know, substantiate it with some experimental studies that you do or someone else has done, and take it as a support. I hope I answered. Is that okay?
Yeah. Nimisha, next question.
We're moving to the next question. This is by Dr. M.M. Ali. He
Yes.
asks, what can be done for those old cities where we cannot change the LULC, where buildings are already existing and almost the entire land was cemented?
And to add to the problem, I will say that is the most critical area in all the cities. I mean, what we observed throughout our study, you take any parameter, that becomes critical. So, but in that case, cool roof works really well, because most of the area is getting covered with the buildings, so roof becomes the major culprit. And if you start painting the roof with cool roof material, that helps. It does help.
Okay.
Yes.
Next question. The next question is by Mr. Syed Muhammad Asim. Hi, this is Asim. Thanks for the great lecture. My question is, what are your views on the practicality and accuracy of simulation programs like Ladybug Grasshopper plugin and Andrew Marsh's application?
I don't know about Andrew Marsh's application, but we are doing these simulations using Grasshopper plugin, and overall simulations, they need to be validated. I mean, if you want to ask me about the practicality and accuracy, the issue with simulations is, since you simplify the geometry, the urban geometry to such an extent that whatever results you get, you cannot, I would say that you cannot go by the number, but you can go by the trend. That means we want to compare. The trend is certainly seen there, but one cannot go by the exact number that one is getting. So we use, and we also validate, whenever we're doing any simulation, we validate it with multiple studies, and then only we take it. Not without validation, I don't think anybody should use simulation results.
Okay. Next question is by Dr. Saurabh Barua. The question is, what should be one fundamental intervention towards mitigation? And his comment is, excellent eye-opening lecture. Congratulations.
Fundamental intervention. The whole idea was to tell you that there is no such one fundamental intervention. But working, instead of, you know, building, I mean, the way we build cities, we hardly bother about the basic layer that the city has. And as of now, the current city planning is strongly dominated by the economics. That means the land cost is high, you start building that. I think we should go by what is the basic, the terrain, and go by nature-based development as far as urban planning is concerned. If that is the fundamental intervention you want to ask me, I would say just build around the nature instead of removing it and building.
We are running out of time.
I have a question before we conclude.
Yes, ma'am. Yes, please.
Should we divide the city into wall city area, new developed area, and future developing area? Because then in that situation, there is a scope for urban planning to put the research into practice to avoid the heat islands. Otherwise, wall city area has a limitation. The new developed area also has certain limitations. We can't destroy and rebuild the area again based on our study. So should we look at the city in this way?
LCZ, ma'am, is a way of dividing the city only. So instead of walled city, it tries to divide or classify the city on the basis of the temperature regime only. So
I
it kind
agree.
of
I
provides a good
agree to it, but
framework.
the intervention plan will be different for 3 zones.
Yes. So you overlay it on that. So this becomes the basic layer. On that, we start overlaying the other layers,
Okay.
and then try to take decisions based on.
In any scope to club the community experience with these simulations so that we are nearer to the reality?
We are trying to do that, ma'am. We are trying to, get the community. You talk about community participation and involving community, right?
Community have a lot of experience of what has happened over a
yes.
period of time in their area, which change the scenario. So if we learn from them, and second is they also know when there is a comfort and when there is no comfort.
Yes. So both these parts we are trying to study. This summer we are doing the same study.
Okay.
So we might know by August exactly what happens when community starts talking about comfort.
And any suggestions to see that the action plans are in implementation?
Ma'am, we are preparing. We have a funded project by NDMA, and we are preparing a model heat action plan for NDMA. One of my
that is wonderful. That is one aspect. No science can work in isolation.
Yes.
And ultimately, it has to go to the implementation phase by the local self-government.
Yes.
So how do we do advocacy to ensure that these wonderful things are learned and accepted, things done by the learners are accepted by doers and it goes into practice? So to begin with, we are going to conduct a workshop, and my student is also, I think, here, Avik Ghosh. So we are planning to conduct when we have the framework ready, we are planning to conduct a workshop before we go ahead and finalize the model heat action plan. We'll have a workshop of all the stakeholders, including the corporation people, as to what are everybody's concerns, so that it can be accordingly, kind of change, modified a little bit here and there. Wonderful. Yes.
Sorry for intervening.
No, I'm sorry.
Yeah, I'm so sorry. We have a lot of questions, and because of the brevity of time, I am just trying to club a couple of questions. There's one question which says, what is the best tool for creating LCZ? And by Ms. Lavani Saha, and Dr. Ajit Tyagi asked, did you relate LCZ with the local vulnerability?
Yes, we are using LCZ to map vulnerability.
Okay.
And the second one, WUDAPT is one tool which is open source available. WUDAPT, WUDAPT.
Okay. Yeah. And another question is from Vilas Majumdar. He asked, what kind of surfacing the road will you suggest and why? And the other thing that is, another question is from Rupal Deshpande. She asked, what could be the first step as a planner should take in the direction of mitigating heat islands to the existing cities?
So the first question is what should be the surface which has a good reflectance. So the surface treatment should be such that less of heat should be absorbed by the roads. First thing is that. Whatever is absorbed by the surface is a part of our budget. Whatever is not absorbed by the city is not a part of, it is not our problem. So as long as a lot of it gets reflected back, then everything is okay. So that should be the kind of surface that the street should have, that the coating that you have should have a high reflectance and high emissivity. So whatever it has absorbed also, it gets emitted. The second question, I forgot. What is the second question you said?
Second question is, what would be the first step a planner should take in the direction of mitigation of heat island to the existing cities?
Existing cities, as I said, that there will not be one single thing, but urban greenery is the key. So try planting, and that to native. That means, in our campus, we have a large area which has fog. I don't know what you call in English for that, but that does not have a single leaf during the summer. So it's like an electric pole basically standing there. Doesn't provide shade, doesn't participate in evapotranspiration. So first thing is plant trees, but what trees? Only native trees. They will survive and they know what to do for that particular climate. I mean, this is not rocket science, but we've forgotten it. So
another question linked to this one is from V Vinoj. The question is, what information do mitigation community need for climate community for these kind of studies? And is it possible to mitigate urban heat island by focusing on rural areas without touching the urban areas?
Rural areas?
Is it possible to mitigate UHI by focusing on rural areas?
Rural areas.
Without touching urban areas that are beyond initiating any measures.
Yes, very much. So this can be divided into two parts. One is where you start, taking measures where the city is already existing. And then you start, like I was talking about LCZ 9, which is in the fringe area. Some of them are urban villages also. So you know that what is going to be their future, because it can either get transformed into LCZ 3 or so you already know what you want that LCZ 9 to become. So based on that, one decides and takes measures and allows it to become something which will not become a heat island. So that is very much possible, very much. I think that's the only question.
Yeah. The last question. The last question is by Anupama Karnam.
Yeah.
The question is there a scope of fine-tuning the Unified Development Control Regulation, which are applicable now for the whole state, including mitigation measures and incentivize such activities?
First thing, I mean, I would like to say that the development control regulations should be on the basis of the climate classification that we have of the city, because climate should decide how the city should develop. Unfortunately, we are treating it as an administrative boundary. So unified development control rules is not a great idea in my opinion, because it kind of removes the importance of the local climate zone that you have. So you are planning cities, the coastal cities, in the same way as you're planning the hilly regions, and the same way as you have the plainer cities. So that should not be. But whether something can be done about it, I think we are in the process of looking into the urban planning component now. So we'll be looking into this unified development control regulations also, and try to talk about them in the context of heat, essentially.
Okay. Dr. Vikas ma'am, for your over to you, Vikas ma'am, for your observations. Yes.
Rajashree, and lot more to do and lot more to learn for all of us.
Yes.
And fact remains that no science can contribute in isolation, and we need to be urban practitioners more, urban and climate resilience practitioners, rather than our own speciality, and try to understand each other to work closer to the requirement of the human health and survival. Ultimately, that is the aim of any intervention. At this juncture, I remember a sentence that what city is facing is our developmental disorders. And that's where we all have to face a problem, and we have to struggle to support the system to rectify and for the human comfort. With that, I thank all the participants who attended this. I am thankful to SAHHIN, and I'm thankful to Irade for giving me opportunity, and it is nice experience to listen to you. Thank you.
Thank you. Thank you.
Thank you, everyone. Thank you, everyone.
Bye. Take care.
Bye.